In the domain of science and grandiose secrets, the subject of what existed before the enormous detonation has blended discussions and charmed personalities for quite a long time. This significant inquiry doesn't challenge how we might interpret the universe. It challenges the actual limits of human knowledge. Imagine standing at the edge of existence, gazing into the vast darkness and pondering what lay there before our universe was born. The moment of the huge explosion marked the dawn of mankind, space, and all that we know. Yet, was there a moment before this? Could there have been a state of nothingness, a silence before the cosmic symphony began? And if so, what was it? Or perhaps, was there something far more frightening that existed before time itself? As we delve further into this question, science takes us on a journey beyond the universe's origin, into ideas that defy our comprehension. Physicist Brian Cox, known for his exploration of the wonders of the universe, proposes that something unnerving could have existed before the huge explosion. He challenges us to rethink our concept of reality and existence. In this exploration, we'll delve into the science, the theories, and the staggering mysteries that could explain what existed prior to everything. We'll examine ideas like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may shock you, but they could also unlock new understandings of our place in the universe. Prepare to dive deep into a world beyond imagination, a science where the unknown still lingers in the shadows, leaving researchers awestruck and sometimes even unsettled. Let us explore what existed before the huge explosion and why these theories challenge everything we thought we knew. To comprehend what could have existed before the huge explosion, we first need to carefully examine what the huge explosion actually was. The huge explosion, as scientists define it, refers to the moment when the universe became unimaginably hot and dense, expanding rapidly to trigger the creation of all matter, energy, and cosmic forces. When we look up at the night sky, we see evidence of this hot beginning, with galaxies spreading out in all directions from a central point. But why did this happen? And was there a time before this dense, hot beginning? According to the theory of cosmic inflation, there indeed was, and it was far from empty or serene. Cosmic inflation suggests that before the huge explosion, the universe was in a state that was cold, empty, and stretched out, almost like a vast vacuum. However, this vacuum wasn't completely empty. It contained an enormous amount of energy that powered the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially laid the groundwork for everything that followed. In a tiny fraction of a second, space expanded at unbelievable speeds until the expansion slowed, and the energy transformed into matter, particles, and the four forces we recognize as the huge explosion. But what was the nature of this energy? Why did it suddenly swell the universe? And why did it stop? Scientists believe that this cosmic inflation created patches of the universe, each experiencing its own huge explosion. Imagine a fabric stretching endlessly, with tiny bubbles forming here and there. Each bubble represents a universe, including our own. This concept, called the inflationary multiverse, implies that there are potentially infinite Big Bangs and an endless number of universes. Ours is just one of many. This vast, mind-bending reality challenges our understanding of the very nature of the universe and leaves us with a question. What else is out there? The concept of nothingness before the huge explosion is theoretical, not actual, at least according to our current understanding. Even if you removed all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create an inescapable tapestry of something, even in its most vacant form. Even if we imagine stripping away all these forces, leaving a dark void, the universe would still generate new forms of energy. This fact alone is confounding to scientists, as it suggests that true nothingness may be impossible within our cosmic understanding. As we probe further, we find that space itself has properties, rules, and constants that do not allow it to be completely void. Imagine creating a region with absolutely nothing in it. No particles, no radiation, and no energy. Yet, quantum fields and fundamental constants still exist, meaning this nothingness has properties. For example, there is a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still momentarily appear and disappear, creating a ghostly echo of activity even in what should be empty space. This defies our concept of a true void and suggests that even before the huge explosion, there was something that scientists are only beginning to understand. One of the most astounding theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible it could continue endlessly. Brian Cox describes a frighteningly vast inflationary multiverse, where universes are perpetually created and keep expanding. Imagine each huge explosion as a spark igniting a new universe, while inflation continues in other regions, creating countless other universes. This process could, in theory, go on forever. This idea of infinite universes gives rise to a fascinating concept of a fractal universe, where each new universe has the potential to create its own huge explosion. Each universe exists as a separate, self-contained realm, unaffected by others due to the rapid expansion of space. For scientists, this theory is both exciting and unsettling, as it suggests an infinite multiverse with no ultimate beginning or end. What if our universe is just one fragment in a massive cosmic structure, expanding and creating endlessly? And what if the startling truth is that there is no before or after, but simply an eternal cycle of universes forming and decaying? Our understanding of nothingness shifts when we consider quantum field theory. According to this theory, the universe is not a collection of matter floating in space. Rather, it's a network of energy fields that fill the universe, interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can appear and disappear in these fields, borrowing energy momentarily before returning it. This phenomenon gives rise to virtual particles, entities that temporarily exist and then vanish, leaving behind a faint memory of their presence. The concept of virtual particles challenges the idea of a true void. Imagine a void. Imagine a void stripped of all particles, radiation, and energy, yet still buzzing with quantum activity. Even in its emptiest state, the universe appears to be brimming with fleeting energy and temporary phenomena. This realization reshapes our understanding of the void, not as an absolute nothingness, but as a dynamic, restless field governed by the principles of quantum mechanics. As we probe deeper, some theories suggest that the nothingness before the huge explosion might not just be physical but philosophical in nature. What if time itself emerged as a result of the huge explosion? If time had no meaning before this event, then asking what existed beforehand might be a flawed question. It could be akin to asking what lies north of the North Pole. In this sense, the concept of before might be entirely irrelevant, as time and space as we know them came into existence with the universe's birth. One particularly fascinating theory proposes that the universe could be cyclical. In this model, the universe undergoes an endless cycle of birth, expansion, contraction, and rebirth. This Big Bounce hypothesis suggests that before the huge explosion, there might have been a previous universe that collapsed in on itself, only to give rise to our own in a renewed explosion. This theory elegantly bypasses the need to grapple with an absolute beginning by positing a perpetual loop of universes, each giving way to the next. Another intriguing concept is the possibility of parallel universes, which ties into the idea of the multiverse. According to string theory and other advanced models, our universe might be just one brain in a higher dimensional space. Collisions or interactions between these brains could theoretically spark events like the huge explosion, meaning that what we perceive as the origin of our universe might actually be the result of interactions in a larger, multidimensional cosmos. The idea of a multiverse also raises profound existential questions. If countless universes exist, each with its own laws of physics, could there be other versions of reality where the rules differ entirely? Perhaps some universes never experienced a huge explosion, while others might be governed by forces beyond our imagination. The vastness of this multiverse concept challenges not only our understanding of existence but also our sense of uniqueness as a species in a cosmos. Yet, despite these theories, the question of what existed before the huge explosion remains one of the most profound and elusive mysteries in science. It pushes the boundaries of physics, philosophy, and human curiosity. It forces us to confront the limits of our knowledge and the possibility that some questions might never be fully answered. What we do know is that the quest to understand the origins of existence has fueled some of the greatest scientific advancements of our time. From the discovery of cosmic microwave background radiation to the development of quantum mechanics and string theory, each step brings us closer to unraveling the enigmas of the universe. And yet, as we uncover more about our cosmic beginnings, we are reminded of the infinite complexity of the cosmos and the endless mysteries that await exploration. In the end, pondering what existed before the huge explosion might not provide a definitive answer, but it inspires us to continue exploring, questioning, and marveling at the grandeur of the universe. It reminds us that science is not just about answers, it's about the pursuit of knowledge and the awe-inspiring journey of discovery. A universe where all matter, radiation, and energy are eliminated. Would you have total nothingness? According to the quantum field hypothesis, you wouldn't. Even in a vacuum, fields remain dynamic, sporadically delivering temporary particles. This steady movement in what ought to be nothing suggests that the universe doesn't conform to our concept of emptiness. Fields and forces persist, filling the universe with a basic energy that prevents absolute nothingness. This understanding raises a fascinating question. If fields create particles and particles create matter, could the universe itself have emerged from this nothingness filled with quantum fields? Dark energy is a mysterious force that currently drives the accelerated expansion of our universe. But did dark energy exist before the Big Bang? According to scientists, it's possible that the dark energy we observe today is a remnant of an energy field from before our universe's formation. Dark energy's properties suggest a vast, enigmatic power that may have existed in some form before the Big Bang. Some theories propose that dark energy, in a much stronger state, might have powered the inflationary phase of rapid expansion. The presence of dark energy implies that, even if our universe were emptied of all matter and radiation, this force would continue expanding the fabric of spacetime. This idea leads to a provocative question. If dark energy existed before the Big Bang, could it have shaped the conditions that led to the birth of our universe? Might dark energy be the silent architect of cosmic expansion, or even the true origin of our universe? As we explore this possibility, we confront the potential of dark energy as not just a force shaping our universe but also a key to unlocking the mysteries of the multiverse itself. Cyclic cosmology. An alternative to the Big Bang. Another theory offering an alternative to the Big Bang as the ultimate beginning is cyclic cosmology. This theory posits that the universe undergoes cosmic cycles of birth, death, and rebirth. In this model, the Big Bang is not a one-time event but part of a cosmic rhythm where universes expand, collapse, and then re-expand in a new cycle. This theory suggests that our universe could have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would mean there was never a true beginning, just an infinite sequence of universes emerging, evolving, and renewing themselves repeatedly. Cyclic cosmology raises profound questions about time, suggesting that it might be circular rather than linear. If this theory is correct, it implies that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current universe. For scientists, this theory offers a rich solution to the question of an ultimate beginning by proposing that there isn't one, that the universe has always existed in some form, transcending our concepts of time and existence. Primordial gravitational waves. Primordial gravitational waves are another intriguing concept that could hold clues about what existed before the Big Bang. These waves are ripples in spacetime caused by massive cosmic events. Scientists believe that if detected, primordial waves could reveal details of the universe's earliest moments. These waves would be remnants from the inflationary period, carrying information about what happened during the first fraction of a second after the Big Bang. But what if waves predate even the Big Bang? Some theories suggest that gravitational waves could originate from the interactions of universes within a multiverse or from events that occurred before the birth of our own universe. These waves could serve as a haunting reminder that the universe itself may have had a complex history long before the Big Bang.